Here's a quick refresher video on order of operations. I'm sure you've seen these things before, but it always helps to be fresh on them. There's a word that people often use to remember these, PEMDAS, or some people say, please excuse my dear Aunt Sally. That's the order of the operations that we've chosen to use. Now you might ask, why do we do parentheses before exponents? I don't know. We decided to, and just like we've agreed that the letter S makes the S sound, if everybody does the same thing when they see that letter, it makes life easier. These are particularly important in the computer age because if you type something in like this into Excel, into the internet browser of your choice, it's going to assume that you are following these order of operations, and you can't talk to it and say, no, I really meant to do addition first. So you've got to know these orders of operations gets more and more important as you interact more and more with technology that is inflexible. It will always do it in this order. Okay, so what do we do in an equation like this? This is an expression. There's no equal sign, so it's not an equation. First, we have to do the parentheses piece. Can you see that inside here, we have an operation to do? So I'll say this is 5/2 plus 7 times x. Now notice there's nothing to do inside here, so I'll just write that. You could write parentheses or just multiplication there. Here there's something to do. That addition gets done first because it's in parentheses. That's how you communicate. I want to do this first. Then I do the exponent, okay? So this exponent applies only to the 3. It does not apply to these things because exponents come before the multiplication. So what I have here is I have 5 divided by 2 plus 7 times x times 9 minus 2. Now what happens is I do multiplication and division together, left to right across. So technically speaking, the first operation that happens is this division. I know multiplication comes first in a little acronym, but left to right, we do these two together. Okay, so what is 5/2? Well, that's 2.5, right? What do we do here? I do 7 times x. Well, since x is an unknown, we just say that 7x, 7 x's, times 9. Okay, 7 x's times 9, you could write as 63 x's minus 2. Okay, so we've used up the multiplication and division. Now we're going to add and subtract left to right, and we're going to add like terms and subtract like terms. These don't have any x's in them. 2.5 minus 2 is 0.5, and here I'm actually using some commutativity because you can add and subtract in any order you want. This 63x has to stay put by itself. Those terms can't be combined. Let's take a look at this problem. Now, this is one of those things, I wish people said this more frequently, because when you have a division bar, what you really mean is that the entire thing above that division bar is in parentheses, and the entire thing below the division bar is in parentheses. That's just fine. We all know you're supposed to do the stuff on the top and the stuff on the bottom separately, but here's the point. If you plugged that into Microsoft Excel or your favorite Internet Explorer, what's going to happen? If you don't put those parentheses between the division, it's not going to know, hey, all of that gets done first. It can't know how long you make that bar. So here's what happens in a context like this, okay? We have, in the numerator, we have x to the third, okay? That means x times x times x, not 2 to the x, not 2 to the third, just x to the third. We have 3 added to that term. Now here's the weird thing about order of operations. I can't do anything to that, okay? This happens first, then that, then this, okay? So the numerator stays like that. So part of order of operations is recognizing, yeah, I have to leave that alone because this is happening first. I don't know what that unknown is, so I can't cube it. Then after, if I knew what it was, then I would have to multiply by 2, then I have to add 3. What about the denominator here? Well, I have 2 times x, so that's 2 x's. Left to right, remember that multiplication happens first. Then I'm supposed to add 2 and subtract x. Okay? With that addition and subtraction step, notice I have like terms. So here's the one thing I can do. I can do 2x minus x. That just gives me x plus 2. So you might say, you didn't do much in that problem. Well, part of simplification is knowing when you can do something and knowing when not to. Okay, so that's how you work that problem. Let's look at this last problem. This is actually solving an equation, and I want to highlight, if you remember order of operations, what's happening is we're trying to get x to itself. We're stripping everything away from the x. Since this is the stuff most glued to the x, we follow order of operations backwards. It's kind of like putting on your shoes and socks, right? You put on your socks, then you put on your shoes. When you're trying to take off your foot gear, obviously you don't take off your socks first. That's a little tricky. You take off the shoes first. So how do I get x by itself? First, I recognize that -1 is least attached, so I add 1 to both sides. Next, I recognize that times 2 is less attached than the exponent to the third. So I divide both sides by 2, so x to the third equals 1/2. Now, the last thing, the most attached to that x, is to the third power. Now, if you don't know how to do cube roots yet, that's okay. But what's going to happen here is you take the cube root of both sides. That's the thing that undoes the third power. And so we get x equals the cube root of 1/2. Hope that helps.